Welcome to our lesson 6.0, which is on the topic of inequalities. Now, the nice thing about inequalities is we're going to use some of our skills from solving equations, but there's a good amount of new notation and vocab is going to come with it, but a lot of that's going to correlate for us. So, with inequalities, it includes the symbols such as these two, which we'll get into details about in a minute, in place of the equal sign. So equal sign goes away and we have these symbols or inequality symbols in place of that. And when we make that replacement, well, that's exactly what we get. We get inequalities. And with these symbols, we end up getting 4 different cases that can occur. We have this, which as we'll always read these from left to right, this is our greater than. Opposite of that is less than. And then if we allow for some equality to happen, things can be greater than, or with that bar underneath it, or equal to. So with that bar, it's still greater than, or equal to. And then I'm sure you guessed it, same here, we're just adding that little bar down below, adding that touch of equality, so it's less than or equal to. Now, with this, as I said, we typically read it from left to right, but more importantly, we want to always read it from the variable to the value it's being compared to. So, for example, this one we would say some number x or some variable x, and then we find the symbol above, we see that it matches with this, so x is greater than or equal to the number 10. So x is greater than or equal to 10. Fit that in there. Now, it is standard for us that we do want to always start with the side with the variable and then compare it towards the value. However, an example of that is if we were to flip this around, so it's no longer in our standard form for equations, which is our same here for inequalities, variable on the left. So if we just read this normally left to right, we would say 10 is greater than or equal to x. However, that's not the standard we're going to go with. We're always going to want to read it from the variable to the value, and we'll learn how we can kind of flip this around, but we could still read it in that other direction. We could say x, and now, well, what is x? Well, we're always going to open that inequality to the larger value, and it's going to point to the smaller value. So that's saying x is now going to be less than, because it's opening up to 10. We got that bar, so or equal to that number 10. So even though this isn't in standard form, we'll always say it or relate it standard from variable to the number. Now, as stated before, these new structures, these new inequalities, they're going to be really similar to how we solved equations, and the fact that we're going to use any and all skills from solving equations here when we're solving inequalities. Well, the big focus of solving equations was getting that variable by itself. Same exact thing here with inequalities. We're always going to be working towards isolating the variable. So the same way we would add or subtract first or do those opposite operations, we're going to see here we're doing the same thing with inequalities. So got 2 examples. Number 1, x minus 4, and it opens towards the bigger value. So x minus 4 is less than 10. And for the second, we have 2x plus 1, and it opens towards the greater value. So 2x plus 1 is greater than or equal to 11. Now, if I made these equal signs, you could knock these out into the problem, and same thing here. So we're just going to go with opposite operations. We have minus 4, so we're going to add it to both sides. 4's will cancel, so that leaves just the x. 10 plus 4 is 14. And then whatever that symbol was, it just comes straight down and maintains that same direction, giving us that x is less than 14. Now, what does that really mean as far as an answer? We'll see that more on the next page. So we'll just do one more example, just showing it's just like a 1 or 2-step equation. I'm going to do my opposite operations, so I'm going to subtract 1 on both sides. Well, those 1's cancel, so I get 2x. I get 10, and again, that symbol doesn't change. It's coming straight down. Then I got some multiplication, so I'm going to divide on both sides. These 2's will cancel, leaving just the x. 10 divided by 2 is 5, just like we do with equations, and then once again, that symbol's coming straight down. So for our first example, you could pick any number for x as long as it's smaller than 14. And if you plug it into the original, that makes it a true statement. And for the example down below, any number greater than or equal to 5, we could plug back into the original and get a true statement. Now, where we just solved equations, we're not going to just solve inequalities. We're going to kind of display our answer in a new fashion, which we'll see on the next page. Now, before we get to how we represent these answers differently, which you get the little hint here with graphing, there is going to be a rare time where on the last page we said that symbol doesn't change anything, we just bring it straight down. There is going to be a rare time to look out for where it can change directions. And that happens when you either multiply or divide by a negative number. So anytime you multiply or divide by a negative number, you must change the direction of that inequality. And we're going to see in 2 examples what we mean by that. So, looking at the first example, see some multiplication. Your instincts are right. We should undo that with some division. But we want to bring that negative with it, right? So we're going to divide by negative 2. Well, negative 2 over negative 2, that leaves just the x. Now, rare, but we did this way back in unit 1.3. 5 divided by negative 2, it's nothing pretty, so we can just keep it a fraction. Totally fair game. But here is the difference. We divided by a negative number. The thing we moved was negative, which means I'm not going to keep it where it's greater than on the left. I'm going to have to flip that around now, so it's going to be saying less than. And that's happening because of this division by a negative. So when you multiply or divide by a negative at any point of these inequalities, you got to change the direction of that symbol. So lastly, we'll have that any number that's less than negative 5/2 will be a solution to the original. Now, example 2 is slightly different. So again, we see some division that we need to do because it's 4 times x. The 4's cancel. 20 divided by 4 is 5, but it's negative. Now here's the weird thing about this second example. We don't change the direction this time. Reason being is we divided by a positive number. 4 is positive. Although there is a negative present on the other side, it's only when that number you move through multiplication or division is negative, that's the only time you got to change that direction. So for that second example, we divided by a positive 4, so that symbol stays the same. Now we can get into what do we mean by graphing with these inequalities. So when it comes to these inequalities, we're going to solve them, how we just kind of saw in those last 4 examples. But then it's a little easier to see our answers displayed, and we do this on a number line. So on that same number line we would have seen in the first unit when we dealt with negatives, we're going to be seeing it here now, and it's going to help us kind of visualize what our answers look like. Well, with these number lines, we need to find a way of showing, what number are we going to work with? Like in this last example, we had -5. What do? Do we put an arrow at it? Do we underline it? And we're going to eventually be using a combination of either open or closed circles on the number line. And that's going to help us decide what numbers we're talking about. And then we're going to do this with a little bit of shading to tell us, are we either going to be greater or less than? Well, what is that difference of open circles versus closed circles? Our open circles are going to be in cases where they're either strictly less than or strictly greater than. That's when we're going to have an open circle on our numbers. And a closed circle is when we get to also include that point. We get to also include that value by being or equal to it. So less than or equal to and greater than or equal to, we're going to be working with closed-in circles. Now, how do we even graph in general? So to graph, you're always going to start at our number value. So if we were to look up on that last example, our number value is what we end up solving for at the very end. So in that last example, we'd start at -5. Now from that value, we're going to use the proper circle as our starting point. So again, we look up at that last example, we were all the numbers greater than -5 and just greater than paired up with an open circle. So on the number line, we have an open circle around the number of -5. And then the very last thing we do is we shade in the appropriate direction based on that inequality. Again, looking at this last example up here, if we had a number line, here's the number 0, 1, 2, 3, 4, here's -5. We would look at -5, that's starting at the number value. We use the proper circle. It's just greater than, so it's an open circle at that value. And then do we shade left or right? Well, we'll see that we want all the values greater than that number. So we're going to shade to the right. So let's see this kind of start to finish with 2 new examples. So again, first we need to solve them. So for our first, we're going to subtract 7 on both sides. We get the x by itself. 16 minus 7 is 9. No multiplication or division, so we don't even need to worry about changing the direction. So we're going to have all the x values less than 9. So we go to our number line. For us, for right now, it's blank, so we can number it how we want. So if I'm dealing with the number 9, I'm going to need quite a bit of room. So I might start down here at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to add in 10 just so I can kind of see where we're talking about. And then I'm just going to run through those 3 steps. Find my number value, 9. What type of circle? Well, it was strictly less than, so it's an open circle. And then what direction do I shade? Well, I want all the numbers that are less than 9, so I'm going to shade to the left. So less than is always to the left, greater than is always to the right. Now we got one more example. We got a 2-step inequality here, so we need to subtract the 1 first. We keep the 2x, that's going to be a 14. Again, no multiplication or division yet, so we can just keep the direction of that symbol. And then for that last step, we need to do some division. And I'll rewrite this over here. The 2's will cancel out, giving us the x. 14 divided by 2 is 7. Now, do we need to change the direction because we divided? No, right? Because it's not a negative number we divided by. So where it was greater than or equal to, it's going to stay the same right here. So now we're going to write out our number line. So we might start saying -1, 0, 1, 2, 3. Get a few values on there so we see where we're working at. And we run through those 3 steps. We're dealing with the number 7. Here it is. This was greater than or equal to. So that's when we need to use that closed-in circle. So at 7, we circle it, but we're also allowed to be that number. So we close it in. And then we want all the values greater than it. So that's always going to be shading to the right. So that is kind of the basics of how we graph it. Now, one last thing we're going to be doing with inequalities is working with giving you a graph and then writing the inequality from it. So kind of going backwards from what we just did, which we'll see on the next page. So coming on to that 3rd page, we have 2 last topics. The main one is the first of talking about writing inequalities from a known graph. So for yours, these 2 should be blank. So I just came up with 2 random graphs for us. So take a moment. You can pause as well and just get those written out, and then we'll work on talking about writing the inequalities from the graphs. So hopefully you paused it, got those 2 written out. So when we write an inequality, instead of just solving it, graphing it, we can also create the inequality itself given a graph. Now, in order to write this, we're always going to start with our variable. So when we graphed, we actually started with that number value, right? For when we write it, we're always going to start with our variable, and we're always going to keep that to the left. Standard form for equations, that's going to be standard form for inequalities. Then once you have the variable, we're going to write out that number value. And that's going to be to the right. So variable is to the left. That number value is to the right. Then the very last move we do is actually choosing which of our 4 inequalities is going to work for us. So this should actually be appropriate inequality, not qualities. So variable on the left, the number we're comparing to on the right, and then which of those 4 symbols is going to fit in between to make it true. So let's see 2 examples. Example number 1, right off the bat, I can write my variable. So say for this one, I like the variable x, but say for the next one, I like the variable a. Whichever one works best for you, you can pick. Now for the first example, I need to see what number are we focused on and you look out here on that number 11 where we have that circle, that is our number value we're comparing to. So I'm going to put that 11 now to the right. Now for the second example, I'm going to do it kind of at the same time. I look and I see that there's either an open and closed circle on this number, -1, which we're also going to write to the right. So now comes kind of the only real tough part of writing it is which of those 4 inequalities are we going to pick from? Well, we get to start at number 11, but as we're shading to the right, we want all the things greater than that number to be included. So we want that symbol to open up towards that larger value. So we want all the x values greater than 11. But then we need to just make sure open circle, if you remember from that last page, means we don't have that or equal to. So for our first example, we're done. Variable left, value we're comparing to on the right. We want everything greater than that value, so it's going to open towards what we're looking for. Now the next example, variable on the left, the number we're talking about and comparing to on the right. Now for this one, we're shading to the left where we want things more negative. We want smaller values. So we're going to be changing directions. We want all the a values that are less than -1. But because this is shaded in, we get to also include that -1. And for us, what that means is we get to be less than or that underline of equal to. So the nice thing about when you're writing these inequalities, it's just observing the number line and creating from it. You're not having to solve or take many steps besides the variable on the left, the number on the right, and picking that right inequality. Now, lastly, before you guys do a couple examples, we come to this topic of translating. So just like when we're dealing with equations or expressions or any of this new stuff, we have terminology or things that kind of cue us in of when to use what. So an example, when we did translating before, products told us multiplication, quantity of told us parentheses. So we have a few key phrases here to help us out to decide which of our 4 inequalities we're working with. So right off the bat, we have our standard 4. So here we have greater than, less than. Now, greater than or equal to. And then that last one we've already touched on, that's less than. It's underlined, so that's or equal to. So those are going to be the 4 standard we go with, but there's just a couple common ones that we have for each 4 of these that are also going to be used in its place. So for the first, where sometimes we might have greater than, another way of saying this that we'll hear a lot is more than. So if you're greater than some value, you're more than that value. These will be interchangeable. Well, you're less than something, you're not more than it, you're fewer than it. So fewer than will be interchangeable with that less than symbol. Now, those are pretty straightforward. There's not an or equal to. The tough ones to remember come with these last 2. So if you're greater than or equal to something, another way to say that is that you are at least that value. So the least thing you could be is that value, and then you're everything greater than or equal to it. So that'll be one we use. And another is no less than, which is kind of counterintuitive, right? You see less than, but we're actually doing greater than or equal to. but it's this no out front to look for, and that's going to be probably one of the toughest ones right there. That no is telling us to kind of do the opposite of what follows. It's negating it. So no less than it means you have to be greater, and that's where we get that greater than or equal to. And then we have kind of two more that are mirrored of these two with the less than or equal to, where this has is at least. If we want less than or equal to something, that means we are at most some value. So we can't go any higher. We have to be less than or equal to it. And then that kind of counterintuitive one, we have one over here as well, as no more than. Again, you see more than, but it's the less than or equal to symbol, but it's that no in front that'll be the tough one to look out for, telling you to do the opposite of what follows. So those are our main ideas. We could solve inequalities. We can graph inequalities. We can write an inequality from the graph. And then we're going to be working with translating some of our expressions and being able to use this terminology. Now, to wrap up these notes, you guys have a couple examples on the next page, 4 examples, where you're going to do a little bit of solving, a little bit of graphing, and then that last number 4, you're going to use some of these phrases to translate before you solve. So give it a pause, give those last page of examples a shot, and then when you come back, hopefully you gave it a pause, gave these 4 examples a good shot, that way you can see what's already sticking, what's not. Now for the first 3, straightforward, we are just solving. So for the first one, we need to divide on both sides. The 4's cancel, leaving just the x. 24 divided by 4 is 6. And although we divided, it wasn't by a negative, so that symbol stayed the same. So now on our number line, you could fill in a few values, a little from the left and the right of what number we're talking about, which for us is 6. So then we look at that number 6. We want everything that's less than it, so not or equal to. So that's going to be an open circle. And then that less than that's already pointing over here to the left, we follow on that graph. So open circle at 6 and graphing and shading everything to the left. Now we got example 2. We're on example 2. We might have an error over here, huh? Because we divided by a negative. And although we divided by a negative, so we did switch that inequality, we didn't graph it appropriately. So this is something I want to bring to your attention, is when you graph it, you're always graphing from that final solved piece. So from this final solved piece, not from any of the original. So though the original had the greater, we need to always graph it from that final standard form piece. So we did have that right open circle at -9, but we didn't want everything greater. We needed to flip it. We want everything that is less than it. So keep that in mind. When we're graphing, we're always graphing from that very last step. We're not using any other piece of that equation. Now, we look down on the number 3. Number 3, you could have done 2 different ways. You could have distributed first and then solved it as a 2-step equation, or you could have seen that it was multiplication, so we could have divided by 2. Either way, you'll end up with this final value, this final form, where we want all the numbers that are greater than or equal to +3. Well, then we go to +3. You see we have an circle, but it's or equal to, so that's where we're getting that closed circle. And then at no point does this inequality change direction, so we want everything greater than that 3. That's always shading to the right. And then we have that fourth and final problem, which is probably the toughest of the 4, because we need to first translate that expression before we can go about any solving. So there's a few key things to look for. One is this less than or equal to. So that's just from our page before, right? That is telling us to use the less than or equal to symbol. Now that means we're going to have something on the left and something on the right, and it mirrors that from the sentence. So what's on the right? Just that negative 18. So we got that less than or equal to symbol. This over here on the right, we get that negative 18. Now we can focus what's on the left. So right, we need a variable, so we have some number x, some variable x, and we have twice that amount. Now remember, twice means to multiply by 2. Now, if this isn't a hint enough that we added some translating, we have an example with translating. If for some reason we're forgetting some of our 1.4 kind of key phrases, I would keep those notes handy in this unit when we're working on problems where you have to translate first. But once it's translated, here we got a one-step inequality. Divide by 2 on both sides. It's negative 18, but the number we divide is positive, so that symbol doesn't change. And then we get x is less than or equal to negative 9, which leaves us our final step of graphing. So I filled out a few values on my number line. We're looking at negative 9, so I'm putting a circle. We get to include that point because we're or equal to, so that's why we got that shaded in. And then we want everything that's less than that value. So everything to the left. So this will be kind of the toughest style of problem we see in Unit 6, where we don't just solve, we don't just graph, we have to create that inequality in the first place with a little bit of translating.